Algebra 2, Unit 1, Equations and Inequalities. In the first unit, Equations and Inequalities, we have 7 lessons. Today we are going to learn the first lesson, Properties of Real Numbers. After completing this lesson, you will be able to classify real numbers and you will be able to use properties of real numbers to evaluate expressions. Now we will see the classification of real numbers. This is the number line, numbers increasing from left to right. All of these are just numbers, but we divided them into various sets based on the properties of numbers. Everyone knows these numbers. Numbers from 1, 2, 3 and so on are called natural numbers. We also call them counting numbers because we use them to count things. Zero and natural numbers together forms a set whole numbers. Now the numbers on the right side of 0 are positive integers. The numbers on the left side, we call them negative integers. Both positive and negative integers, including 0, are integers. Therefore, integers are both natural numbers, whole numbers, are both positive numbers, negative numbers, and 0. Therefore, natural numbers and whole numbers are the subsets of integers. Now let us learn rational and irrational numbers. Numbers that can be expressed as fractions or in the form of p over q, where pq belongs to z and q is not equal to 0, are rational numbers. In other words, all the fractions are rational numbers if both numerator and denominator of that fraction are integers and denominator is not equal to 0. Rational numbers look like fractions, but both numerator and denominator are the integers and denominator is not equal to 0. We will see some examples. 5 over 6 is a fraction, therefore it is a rational number. Negative 19 and square root 4, both are rational numbers. Negative 19 over 1, square root 4 is perfect square, which is equal to 2. 2 over 1 is a fraction, therefore it is a rational number. 0 is a rational number. 9 is also a rational number because 0 over 1, 9 over 1 are fractions. 5.62 is a repeating decimal. This can be expressed as fraction, therefore 5.62 bar is also a rational number. Square root 16 over 8, square root 16, which is 4 over 8 is a fraction, therefore this is also a rational number. 0.25 is a quarter, it is a rational number. Now we will see irrational numbers. Numbers that cannot be expressed as a fraction is irrational number. Irrational numbers cannot be expressed as fractions. For examples, square root 3 is irrational number. If you plug square root 3 in calculator, you get a long decimal and numbers are not repeated and obvious. You cannot express square root 3 as a fraction. If you see the second example, square root 5 over square root 10 looks like fraction, but if you simplify it, it is square root 5 over 10, which is square root 0.5, which cannot be expressed as fraction. So this is also irrational number. Pi, of course, it is an irrational number. Negative square root 7 is also a rational number because we cannot express square root 7 as fraction. So far we have learned irrational numbers and rational numbers. Irrational numbers cannot be written as fractions. Square root 2, negative square root 5, and so on. Rational numbers can be expressed as fractions. Half, which is 0.5, 2 over 3 is 0.6 bar. This is a repeating decimal. And we have integer set. As we have seen at the beginning of this lesson, both naturals and whole numbers are the subsets of integers. Integers are not decimals. Please remember, integers are not decimals. Now both rational numbers and irrational numbers together form real numbers. Therefore, real numbers are both rational and irrational number. In other words, both rational and irrational number sets are the subsets of real numbers. Now let us see some examples. Name the sets of numbers to which square root 6 belongs. Root 6 cannot be written as fraction. Therefore, root 6 is irrational and of course it is real number. Example 2. Name the sets of numbers to which 5 belongs. We know 5 is a natural number, therefore it is a whole number and it is also integer. 5 can be written as 5 over 1, therefore it is rational, therefore it is real. So 5 is natural, whole, integer, rational, and real. Example 3. Name the sets of numbers to which negative 2 over 3 belongs. Negative 2 over 3 is not an integer because it is fraction. Negative 2 over 3 is a rational number because there is a numerator and denominator is not 0, and both are integers, therefore it is a rational number, therefore it is a real number. Example 4. Name the sets of numbers to which negative 3.15 bar belongs. As we have seen, negative 3.15 can be written as fraction, therefore it is a rational number, so it is real. Now we will place some numbers on the number line. These numbers are not integers, therefore we got to be careful when we plot these numbers on the number line. First we will start with square root 3. Square root 3 is an irrational number. Square root 3, if you plug it in calculator, it gives 1.732 and so on. Therefore, we place square root 3 right here, 1.732. Then we have negative 1.5, which is on the negative side of the number line. It is right there. 1/4 is quarter. It is positive number right after 0. 4.55 bar is a rational number because 4.55 is a repeating decimal, non-terminating, which can be expressed as fraction. 4.555 is right here. We have 0. Negative square root 6. Square root 6 plug it in the calculator, we get 2.449 and so on, which you can place here. This is how we place numbers on the number line. Now we will see the properties of real numbers. Properties of real numbers are important in order to solve the problems. Let A, B, and C are real numbers. The commutative property is A plus B equals B plus A, which means you add numbers in any order, you get the same result. This is valid only for addition, not for subtraction. A minus B equals B minus A is a wrong statement. But this is also true for multiplication. A times B equals B times A. Commutative under multiplication. Now we see associative property. A, B, and C are real numbers. A, B, and C are real numbers, and we group them in different way, but still we get the same result. A plus B in one group and add it to C, and on the right side, B plus C is one group and add it to A. We get the same result. This is associative property. Associative is true under multiplication also, but it is not true for subtraction. Identity. Identity is a number. Additive identity is 0. Multiplicative identity is 1. And finally, we have distributive property. This is very important property. A times B plus C is equal to AB plus AC. We're going to use distributive property in many equations. Generally, we make a mistake of not multiplying C or the second term by A. We got to be careful not to make this mistake. Now let us see the entire list of properties of additions and multiplications. You may make a note of this. This is also available in david.school. Now let us see some examples. Name the property illustrated by negative 8 plus 8 plus 15 equals 0 plus 15. This is not commutative property because A plus B is not equal to B plus A. Also, this is not associative property because on the left there are 3 terms and on the right there are only 2 terms. You may tend to say this is identity property, but that is not true. Here, negative 8 plus 8 is equal to 0. Negative 8 and 8 are inverse to each other. Therefore, this is additive inverse property. Example 6. What is the property illustrated by 3 plus 0 equals to 3? It is not distributive. It's not additive inverse because it's not saying 3 minus 3 is 0. Therefore, it is identity property of addition. Find the additive inverse and multiplicative inverse for 5 over 7. As we have seen before, a number and its additive inverse gives you the result 0, or simply change the sign. Therefore, the additive inverse of 5 over 7 is negative 5 over 7. A number and its additive inverse gives you additive identity. In order to find multiplicative inverse, Flip the number but do not change the sign. The multiplicative inverse of 5 over 7 is 7 over 5. Multiply a number and its multiplicative inverse gives you multiplicative identity 1. Find the additive inverse and multiplicative inverse for negative 49 over 7. As we have seen, the additive inverse simply change the sign. Therefore, it would be square root 49 over 7. Multiplicative inverse. Keep the sign as it is, just change numerator into denominator and vice versa. We'll see one last example. Find the additive inverse and multiplicative inverse for negative 6. The additive inverse is positive 6 and multiplicative inverse is negative 1 over 6. Now let us simplify some expressions. Using properties of real numbers, we will simplify these expressions. Use distributive property. It will be 4 times 3a is 12a minus 4b plus, and use distributive property again, 2b plus 2 times 3, 6a. Now multiply these numbers. 4 times 3, 12a minus 4b plus 2b plus 6a. Now we group the numbers. 12a and 6a are similar numbers, so we group them, and negative 4b plus 2b are similar numbers or like terms, so we group them. And now we use distributive property again, which is 12 plus 6 times a plus negative 4 plus 2 times b, which is 18a minus 2b. Question 11. Which expression is equivalent to 2 times 3x minus y plus 4 times 2x plus 3y? We use the same method we used before in example 10. Then we would get 14x plus 10y, which is answer A. We see an application. Sophie went to post office and bought 8 42-cent stamps and 8 27-cent postcard stamps. What was the total amount of money Sophie spent on stamps? Since the price of stamps and postcard stamps is given in cents, we change them into dollars. 42 cents is $0.42. 27 cents is equal to $0.27. We can solve this problem using two different methods. In first method, we multiply then add. Multiply the price of each type of stamp by 8, then add. 8 times the price of each stamp and 8 times the price of postcard stamp. Then simplify, we get 5.52. In method 2, we add them first and then multiply. Add the prices of both types of stamps and then multiply the total by 8. We get 8 times $0.42 plus $0.27, which is 8 times $0.69, which gives you 5.52. Sophie spent a total of $5.52 on stamps. Notice that both methods result in the same answer. Now we will see one last example. Joel went to the grocery store and bought 3 plain chocolate candy bars for $0.69 each and 3 chocolate peanut butter candy bars for $0.79 each. How much did Joel spend altogether on candy bars? We first multiply and then add. We get 4.44. Congratulations! Now we have completed this lesson. In this lesson, you have learned how to classify real numbers, how to use properties of real numbers to evaluate expressions. Thanks for watching. Auf Wiedersehen.